Hi, I welcome all of you in my channel and in this video in which I am going to discuss a real problem based on multiple regression analysis. Shortly, in fabrication industries there is a huge problem of sound. The sound has been measured in decibels. There are few factors that we have taken into account to predict the sound. The factors are frequency, degree, angle in degrees, chord length, velocity, displacement. Based upon these factors, we have to predict the sound level. So I will perform this the whole multiple regression analysis in Excel, in Minitab and SPSS. For this purpose, 1503 datasets has been collected. In this video, I will discuss hypothesis formulation, analysis, interpretation, recommendations, conclusions of this whole problem. So the null hypothesis represented by H naught is frequency, angle in degrees, chord length, velocity, displacement do not statistically predict decibel. And alternate hypothesis represented by HA, again the same statement except that it will statistically predict decibel. Let me make a little bit correction that we can write it here sound, and with the sound in the brackets it's good to write decibel, that we are measuring the sound in decibels. To perform the multiple regression analysis in Excel, go to data, then go to data analysis tab. In the data analysis tab, we will have to enter both input variables, and input variables are known as my independent variables, or sometimes we can say them as our predictors. So input y range and input x range. So y range is our dependent variable. Click on this upward arrow, then click on this decibel, click on shift, control and down arrow on your keyboard, press enter. The whole data has been selected easily. Then go towards the top. Then we have to input x range. Click on this up arrow, click on this frequency. Don't select these contracts. Then from the frequency till displacement, select all of them. Shift control down button, down arrow. Okay, fine. Now there are labels in the first row of our Excel data sheet. These are the labels. So click on this, that we have label in our first data sheet. Click on their output range, and I need my results in there in this cell. So let's click OK, and after that you have to just click OK. We will get the results. Now I am going to discuss the results. I have copied all those results in the Word file and now that have been written in the APA style, and I will discuss all of the results. A multiple linear regression was performed to predict sound in decibels based on frequency, angle in degrees, chord length, velocity and displacement. The R square of the model is 0.3622. Let me show you where is R square. So in the result, this is R square 0.3622. It explains that 36.22% variation in the sound decibel has been due to frequency, angle in degrees, chord length, velocity and displacement. Now to check whether our model is significant or not, we will have to look at this ANOVA table, this F value and P value. Okay, now I'm going to show you the report. A significant regression model was found with F5, 1497. This 5 is the degree of freedom for the regression. Here degree of freedom DF, and 1497 is the degree of freedom for the residuals, is equal to 170.03. This is the F value we have obtained there. Okay, after that comma P is equal to 0.000. So this is our P value. Therefore the null hypothesis is rejected and alternate hypothesis is accepted. That model significantly predicts the sound in decibel based on frequency, angle in degrees, velocity, chord length and displacement. Now the next step is removal of the insignificant predictors from the model. So we can see the frequency p value is less than 0, angle in degrees greater than 0.05, chord length again greater than 0.05, and for velocity and displacement the p value is less than 0.05. So we have to eliminate two predictors from our model, angle in degrees and the chord length. The p value of frequency, velocity and displacement is less than alpha is equal to 0.05. therefore found significant and retained in the model. The angle in degrees and chord length have a p-value greater than 0.05, therefore found insignificant and deleted from the model. Our predicted regression analysis equation in the coded form is, because instead of writing the full name, I have coded them like x1, x4 and x5. Whereas in the uncoded form, you will have to write in place of x1 as frequency, x4 velocity, x5 displacement. Further, we can see from this equation number 3 that frequency and displacement has a negative impact or relation on the sound. It means that with the increase in frequency and displacement, the sound level decreases. It also means that if a person or a worker is far away from the source of sound, so that worker will hear less sound. It can be interpreted that with the increase in 1 unit of frequency, there will be a decrease of 0.00111 units in the sound. With the increase in 1 unit in the velocity, there will be an increase in 0.0832 units increase in the sound. Further, with the increase in 1 unit in the displacement, there will be a decrease of 240.505 units in the sound. So based upon the data, we found that the company have to purchase the expensive equipment for the people who are working near the source of the sound and the people who are working far away, so company can purchase the standard earplugs for the rest of work envelope. Further, in the industries, it is compulsory to apply the National Institute of Occupational Safety and Health. Now I will perform the same analysis in the Minitab and it will take only 30 seconds. Copy and paste the whole data in the Minitab, go to stat, then go to regression, again regression, fit regression model. Here you will have to select the response. Decibel or sound is my response variable. However, then click on the continuous predictors, frequency, angle, select all of them one by one. Okay, and just click OK. You will get the same results as those of Excel. In order to view the result, click on this window tab. Here we got the ANOVA table and the same result, that angle in degrees and the chord length is found to be insignificant. In order to perform the SPSS, again I will suggest you to copy the data from the Excel but without variable name. So I'm going to select only the data, because in the SPSS we have to enter manually all of the labels. So I'm going to SPSS, copying, pasting all of the data from the Excel in the SPSS. Data has been copied. In order to save the time, we know that our variable 6 is our response variable while the rest of 5 are my predictors. Go to analyze, then go to regression, linear regression. Here we will have to select that variable 6 is my dependent variable, whereas variable 1 to 5, these are all of my independent variables. Click on them, just click OK, and you will get the result for the multiple linear regression. The same result we will get over R square value 3.622. This is my ANOVA table, and here is my coefficients table, and we got the same result that variable 2 and 3 are found to be insignificant. So thanks a lot for watching the video. If you have any comments, you can ask me on the WhatsApp as well as in the comment section of the YouTube. Please like the video, subscribe to my channel. Bye.